Okay, so we're starting the last section in chapter 1, section 2.3. And in this particular section, there's a lot of word problems, a lot of different things that are going to be going on. And the first thing that we have is it's a lot of what I refer to as chug and plug. You've got values, you're plugging them in, you're evaluating it for a particular variable. So a lot of times this stuff will be literal equations, meaning you're solving in terms of a variable or not. So that's kind of how it's set up. But we're looking at volume of a cylinder, and that's pretty straightforward. Volume equals pi r squared h, right? The radius is 9, the height is 7, and answer exactly using pi, right? So leave your answer in terms of pi. So volume equals pi times, that would be 9 squared, and then times 7. So doing this would be what, 5 times 81 times 7, which is 567 or something like that. Yeah. Okay, so volume equals 567 pi. Any questions on that? Pretty straightforward, just a chug and plug. The biggest thing you've got to make sure you understand is when you type your answer in, you go 567 pi. And that pi will put up a pi symbol, right? So that's what it's referring to. Any questions on that? Good?
Honestly, sure you put your pi in because the x plus equal 1
Did you try to put it in the beginning? Yeah. Sometimes format does become an issue. All right. So let's kind of look at this one. This is a two-part, right? It says solve for W. So we're basically looking at the perimeter, right? So the perimeter equation is P equals 2 times length plus 2 times the width. So 2L plus 2W. Now, we are, move this over. We're going to be looking at this, and so we need to, the first top part says solve for W. So this is a literal equation, right? It's got multiple variables. It's already solved in terms of P, but you need to turn around and solve it in terms of the width, right? And if you're looking at this, if I'm solving for W, I need to get W by itself, right? So that means I need to move the minus 2L over. So that's going to give me P minus 2L equals 2W. And of course, guys, we would divide both sides by what? 2. Right. So W would equal P minus 2L over 2. So when you put that in, you can put it in as a fraction. Just make sure that you put parentheses in case everything in the numerator. All right. So down in the bottom, we're going to be looking at, it says solve for the width or find the width if you're given a length that's 10 and then a perimeter which is 34. Guys, we're just going to use this equation, right? W or width equals P minus 2L over what? 2. So just like I said, straight chug and plug. 34 minus 2 times 10 over 2. So that's 34 minus 20, which would be what? 14 divided by 2 equals what? So the width would equal 7. All right. When we're looking at this particular problem, I want to show you an algebraic technique, and then after that, I'll let you go and solve it, okay? But I want to make sure we're all on the same page. They've given us this formula, force equals mass times velocity squared over resistance, right? So F equals mv squared over big R, right? If you remember, things that are diagonally across an equal sign can be swapped out with one, right? Y'all understand what I'm talking about? So this F and this R, we're going to switch places with those. It goes back, or it lends itself back to the proportions type, the cross product type things. And you could either look at it from a quotient or product properties of equality. So what it's going to allow me to do is this. R and F swap. Like if I multiply both sides by R and then divide it by F, I get what's in red, right? So just know that that algebraic technique works. Now you can plug in the what? The M, the V, and the F and solve for who? R. So take about 25 seconds to do that, please. Okay, so when you plug all this in, you get R equals what, 54, and V is 7 squared over 441. Anybody got a final answer? 6. Any questions on that?
So when you do this, even though that's the formula,
Yes.
do we always switch and you still get the same answer if you don't switch?
You'll get the same answer if you don't put it in, switch it. But you'll just have R down in the bottom, right?
Okay. Yeah. Okay.
So, yeah. It's easier to just go ahead and manipulate with that algebraic technique than it is to kind of plug it in. It's kind of dual purpose, literal equations, solving for particular variables. All right, so let's look at this one. I'm going to give you this series that produces consecutive integers. I'm going to give you, so it says 2, but you need to kind of look at it like this. X plus 1, X plus 2, X plus 3, X plus 4, and X plus 5, right? That series or sequence will produce, if you're given an X value, it will produce consecutive numbers, right? So that's what you're going to use to solve this or work with this. These numbers are not that difficult. If you think about 2 consecutive integers is 7, well, I mean, do we need to actually do the work for that one? What's 2 numbers when added together that are consecutive? That means one right after the other. 3 and 4, right? But what if it wasn't 7? What if it was something crazy like, I don't know, 220? Right? So you just kind of look at it like this. We're going to do the sum of 2 consecutive integers is equal to 7, right? So we're going to grab 2 of these because I need just 2 of them, right? If they said find the sum of 3, then I would grab 3 of those little pieces, correct? So I'll go x plus 1 equal to 7. And then I'll solve. So let's see what you can do. Take about 15 seconds to solve that. Okay, so when we combine like terms here, we're going to go 2x plus 1 equals to 7. Minus 1 from both sides, so 2x equals 6. X is going to equal 3, right? Okay, so we plug this back into this little sequence here. There's 3. So the smallest number is 3. 3 plus 1 equals what? 4. There you go. And those added together, they better equal to 7. So that checks out. Any questions on that? All right. On this one, we're going to have a little fun with this one, okay? The cost for long distance phone calls 45 cents for the first minute, 34 cents for each additional minute. If the total charge for the long distance call is $8.95, how many minutes was the call? So here's what I want you to do. 9 times out of 10, you can do this, what I call logic, right? If you're old enough, and when I say old enough, you don't have to pay for long distance calls anymore, unless you use a landline, right? But people aren't using landlines. So if you're young and if you young whippersnapper, the long distance really doesn't come a factor for you because you don't truly understand what it really meant to have a long distance call, right? So I want to see if you can take about a minute to see if you can reason out what this would be, right? How many minutes was the call if it cost $8.95 in long distance? Okay. So go ahead and take about a minute to see what you can do. Here we go. All right, so we're gonna go old school on you, okay? So the first minute costs how much? Okay, so we're gonna take $8.95 minus 45 cents, right? That's gonna leave me with $8.50. Y'all agree? Okay, so that's for 1 minute. Now, the rest of that time costs how much? Okay, so I'm gonna take $8.50, and I'm gonna divide it by 34 cents. Now, well, I shouldn't draw that little line there. Clean that up a little bit. So I'm going to divide it by 34 cents. That's going to give me what? 25 minutes. Ladies and gentlemen, 1 plus 25 equals how many? 26. Okay. Oh, forgot about that 1 minute that cost something else. It did. It was at a different rate, but what was my balance? $8.50. That was at how much? 34 cents. Right?
Oh, I see the total was like the total for all of it, and then you take the.
Yeah, we did. We did. We took that 1 minute off right here. Right? So this one to mess with you, okay? So that's okay. Listen. When I looked at this, I had to think about it. I could do it logically, but then I had to think, okay, how do you do this algebraic, right? So let's just kind of go like y equals, well, what's the slope, period? If we didn't have that first minute being 45 cents, what would you say the slope or the rate per minute would be? 34 cents, right? Y'all agree? Okay. Well, because we have so much at 1 minute, and so much, the rate change is different, then you're going to have to do things like this. Okay? So that's actually the problem algebraic. 34 cents times x minus 1 plus 0.45, right? Now, here's how it works. That first minute, so let's plug in that first minute for x, right? So 1 minus 1 is what? 0. 0 times 0.34 is 0, right? So that first minute only cost me how much? 45 cents. Second minute, 2 goes in for x. 2 minus 1 is what? 1. 1 times 34 cents is 34 cents plus the 45. So that little pattern's going to add up, right? So if I were to solve this, the 895 would be my y, right? That's my output. And then I would distribute this. And then I combine my terms here. And that would give me what, 10 cents? And of course, then I would move my what? 10 cents over, right? Or I move that to 99. I can't do that, so I'm going to do that. 0.10, right? So what's that going to give me? 10 cents off of that's what? $8.85 equals what? 0.34x. And of course, folks, we're going to divide both sides by what? So what does x equal? 26, right? So there you go. So you have it both ways, right? You would probably, 9 times out of 10, probably do it the left side, right? Mm-hmm. Yeah. Just because that's a real world type application, right? Yeah. But the right side is, guys, that's how it works, which is cool. Now, let's say it was 45 cents for 3 minutes. Then how would that affect this right here.
So it's 3.
You'd have an X minus 3, but you'd have some other stuff, because then you'd have 45 cents only having ones, right? So you'd have to adjust for a little bit more for that. But well, you'd have to do what? $0.45 for 2 to 3 minutes, right? The total of that 0.45 would change by that. So, all right. So let's look at this one. All right. Hey, we're going to Vegas. So I hope you got your bags packed. Okay. So Shane returned from Vegas with $400, which was 25% more than he had at the beginning of the trip. So he got there, he went through the trip, he come back with $400, which was 25% more than what he began with. Okay, how the heck did we find out how much he had at the beginning of his trip? Yeah, we're gonna do something. I don't, it's a little bit more than multiplying, but we're gonna look at it in terms of some things. But I want to see what you can do. Okay, so how much did he have at the beginning of his trip? He had how much? 300.
Because that's 300. Well, that would be 25% less.
No, I know we did wrong. We're supposed to start with we took 25% of it.
Algebraically, this is what you do. Do we know how much he left with, just out of curiosity? No. So in math, what would be assigned to that? X. But we know that during his trip, he had a 25% increase, right? He gained 25% more, right, of what he had, right? That was all we could do. $400, right? Now, I want to show you something. This one represents, guess what? 100% of the money he had, right? That 0.25 represents, guess what? 25%. So if we combine like terms, we have 1.25 x equals to what? 400. And of course, we'll divide both sides by 1.25. So x is what? $320. Correct? Any questions on this one? Anybody? Raise that up a little bit. Y'all good? All right. Do this. All right. So we good on the 320? Yes. All right. So I want to go back. There was an error here in this problem previous. That's not 10 cents. That's what? 11. So that would be what? Y'all agree with that? 884, correct? Y'all good now? So all is well that ends well, right? Okay. So double check me, because some of this stuff I'm doing in my head. If I do it in my head quick, guess what happens? Errors. All right. Now, the greatest problem of all time, the train problem. Right? So we got train A that has a speed of 25 miles per hour, greater than that of train B. If train A travels 240 miles in the same time that train B travels 190, what are the speeds of two trains? The question is, who cares? Right? If you're on the train, as long as you get there in enough time, you're good. But they're going to expect us to be able to solve this, right? So again, remember that this is algorithmically generated, right? So it means that the only thing that's going to change is the numbers. Now there is another train problem that you have two things or a plane headed in opposite directions, right? In this thing. So here we go. I want to talk about this. So let's go. What we're going to use is distance equals rate times time. that is the primary equation that we use on the plane one, the train ones, plane, trains, cars, and automobiles, right? Yeah. So I like to do this, train A and then train B. And I label my information. I know I got a D, an R, and a T. All right, so let's go figure out what they say about train A. Train A has a speed 25 miles greater than that of train B. Well, do we know how fast train B is going? Yay or nay? So we're going to put X on the rate for train B, but we could do what here? X plus what? 25, right? You okay with that? Now, they have to give us, because there's three variables, they have to at least give us information for two, right?
Yes.
Train A travels 240 miles in the same time that train B travels 190. So that 240 and 190 are distances. So that's 240 and that's what? 190. Okay, ready? So kind of like what we did before, we've got time, right? So we need to solve this equation in terms of time. If we do so, it's divide by R. Let me do this in red so you can see it. Divide by R to both sides. So time would equal D over R. You with me?
Mm-hmm.
All right. So the key to this is they are traveling at the same time or the same amount of time, correct?
Mm-hmm.
Okay. If train A travels 240 miles in the same time that train B travels 190, what are the speeds of two trains? Their times are the same, so therefore I could set their equations what? Equal to one another, right? So what I've got is this. I've got 240 over X plus what? 25. That's for train A. And then I have 190 over what? X, right? All right, so I've got a fraction equal to a fraction. So what do you think we're going to do? There you go. One 90 times 25 is what? 4750. Y'all agree with that?
Yes.
All right, good. Subtract 190x. That's 50x equals 4750. And of course, divide by 50. So x equals 95. Okay. That is miles per, guess what? Hour. Right? So this x is solved for who? Train B, right? So train B is traveling at 95. But train A is traveling at what?
95 plus
95 plus 25, which is 120. Now, does that make sense? Train A traveled 240 miles, while only train B traveled 190, right? So in the same amount of time, A's got to be going faster than B, right? Okay. Any questions about how we did this? D equals R times T is going to be our plane, trains, and automobiles questions, right? Going in opposite same direction, leave at the same time, all this other stuff, right? 15 minutes later, those type problems. So I solved in terms of t because times were the same. If times were the same, then I could set their information equal to one. They're congruent, right? So, yay or nay? All right, let's go to next. On this one, it says the length of a rectangle is 2 meters less than twice the width. The perimeter is 44, find the width. Well, it's better if we draw a rectangle, right?
Mm-hmm.
Rectangles always, or shapes are always great when you're drawing things. Label them, all this great stuff, right? So, you go, well, I can't do that. I need to do this over here, like length and width and then perimeter, right? So we know that the perimeter is 44. Y'all agree? That's 44 meters. The length of it is 2 meters less than twice the width. Well, I don't know what the width is. Do you? No. So the width on this is going to be, guess who? X. And once we make that determination that the width is X, now I can go back and apply that in an expression based off the relationship between the two. 2 meters less than 2 times the width. Anytime you see less than, something less than, that particular number is going in behind that, right? Or if it's less than, greater than in the front, it goes towards the back. If it's in the back, it goes to the what? To the front. Y'all remember all those verbal algebraic stuff? That's kind of what they're leaning on. So I've got 2x plus what? 2? No, it said less, right? Sorry. It says less. My bad. 2x minus 2. So I've got, let's see. Here's 2x minus 2. Here's x. And we know the perimeter, which is all the way around it, right, is 44. So it's easy to just use the perimeter equals 2 times length plus 2 times width, right? And you're just plugging in. So any questions about how we've got this set up thus far? Anybody? All right, I'm going to give you a little bit of time to go ahead and work that out. Find the width and the length. All right, good. Okay, so if we look at this, this is 2 times 2x minus 2 plus 2 times x, right? I'll substitute those in. Note that I'm putting them in parentheses. Okay, so it's 44 equals 4x minus 4 plus 2x by like terms. That's 6x minus 4 equal to 44. And now I'm just adding 4 to both sides, right? So that's 48 equals 6x. And of course, guys, x equals what? 8. So when we find x equals 8, that means the width is 8 and the length is 2 times 8 minus 2, which is what? 16 minus 2, which is 14. Now, it didn't ask for the length, did it? It asked for the who? The width, right? So just kind of make sure when you're solving for these, I tend to if I've got one, I just go ahead and plug it in, and then I'll go in and look and see what problem asks. Right. Any questions on this one? Oh, good. Mark and Don are planning to sell each of their marble collections at a garage sale. If Don has one more than 4 times the number of marbles Mark has, how many does each boy have if they sell? How many does each boy have to sell if the total number of marbles is 96?
That's a consecutive number.
Nope. No, not a consecutive on this one, right? It is very much like the problem we just worked with rectangle, right? So we've got to go what? Don and who? Mark, and then total, right? And looking at this, we should be able to know that the total number of marbles is how much? 96. Good. So Don has one more than 4 times the number of marbles Mark has. Do we even have a clue on how many Mark has? Mark's lost his marbles. He doesn't know. So Mark is X. But Don has one more than 4 times that, right? What would that be? 4x plus 1. Good. All right. So can you set up an equation and solve for x now? Let's see what you can do. I'm going to kind of back off. I'm going to stop there and let you go. All right. What would the equation be on this?
X plus 4x plus 1 equals 96.
That's right. 4x plus 1 plus x equals 96, or x plus, yeah. It doesn't matter which one you put first. It's Don plus Mark, right? Or Mark plus Don. So we're going to combine like terms. That's 5x plus 1 equals 96. Minus 1 from both sides. 5x equals 95. See these pretty numbers? Minus 1, it gets you back to a number divisible by 5. What is that? 19? So x equals 19. So x represents who? Mark. So Mark has 19 marbles, right? What's 4 times 19?
76.
Plus 1.
77.
77. Good. Do those two numbers add together to give you 96? Okay, so check. Huh?
I got more. I didn't get
Okay, you got Mark being 19? Okay, so if you plug x in, or 19 in for x here, 4 times 19 plus 1. Or you could have said, hey,
Yes, I did 96 times.
no, 96, you might have typed something wrong. Did you do it on paper or in the calculator? Yeah, that should be 77, right? It'll be 16 minus 9, which is 7. Carry or bar 1 from my 9. Get 8 minus 1 is 7. 77. Either way, it's, there you go. There you go. All right. Any questions on this? Y'all good? This is the last one in this section. Okay. There's one more that's printed out, but that one's I'll talk to you about that. All right. So we got 2 different telephone carrier plans that someone's considering. The first one is Company A that charges $20 monthly fee plus 10 cents per minute for calls, and then one that says 10 minutes monthly fee and then 15 cents per minute for calls, right? So they say, okay, find the model of the total cost for both companies for 1 month using M. So if you don't use M as your input variable, guess what's going to happen when you get into XYZ? You may have it correct, but if you use X, guess what? It's going to count it wrong. It's looking for M, okay? So please use M. If you get to the test, if this happens to be one in the test and you put X, then I'm going to go back and we'll give you 95% of credit. Does that make sense? It'll count it totally wrong, but I'm going to go back and give you 95. I mean, because the math is more important. Yeah, you just didn't know how to read it, or you forgot. Or you like me, everything's X, right? All right, so I need you to write 2 equations here, okay, based off this. I want you to think about what it says for like charges fees, monthly fees, and then what these 2 things are from a linear equation standpoint. So take about 20, 30 seconds to write me 2 equations. All right, so this is what you get. Company A, this $20 monthly fee, guys, if we're looking at it from a linear standpoint, that's our initial value, or a B, or Y-intercept, right? When you do nothing, you got to pay that, right? Mm-hmm. And then this 10 cents per minute, that's our slope, correct? So what we have here is 0.1 M plus $20, right? And then for company B, we have 0.15 M plus 10, right?
Would we have got it wrong if we wrote the opposite way?
What do you mean?
I wrote 20 plus 0.1 M.
No.
It's just because I read it that way.
Yeah, that's correct. If you would look at it, but traditionally we'll go MX plus B, but is it wrong if it's that way? No. Because associative property, no, not associative, commutative property of addition says, if you're adding two things right there, you're good, right? Okay. So we can switch them around. How many minutes of calling in 1 month? 1 month would the two plants equal? So what do we need to do to these two equations? What does that mean?
Make them equal each other.
Make them equal one another, right? So 0.1 m, I just wrote that wrong. I said it, but I wrote it wrong. 0.1 m plus 20 equals to 0.15 m plus 10. And if you solve this, and I'm going to let you solve it, so go ahead and solve it. So what we have, it's going to come up here, we're going to have 10 equal to 0.05 m, and then divide both sides by 0.05, and that is how much? How much? 200. So at 200 minutes, both plants would equal the same, right? So who would be cheaper if it was less than 200? If you use less than 200 minutes a month, who would be cheaper? And then who would be cheaper if you went over 200 minutes per month? That's what the next question is asking, basically, right? But they're giving you a set value. They're saying, hey, if the person makes an average, monthly average 150 minutes of calls, which plan would be the best? Would it be company A or company B? Well, we take that 150 and we plug it in for both equations, right? For the M and in doing that, we get, okay, what's 0.1 times 150? Anybody? I think I might calculate. 0.1 times 150. 15? Oh, 10% of 150. Yeah. Okay. 15 plus 20. Sometimes it works, okay? So $35, right? Okay, so okay, hold on. Let me get this. That's 15 plus 7. That's 22 and a half, right? Okay, good. See, brain's working again. Plus 10, which is 32.50, right? So company B, if you're less than 200 minutes, right? Really, company B is going to be your best bet, and because it's your best bet at 150, right? Because it's kind of like this, like you're looking at this. All right. So let's say that this right here is company B, right? Correct? It's company B, and then this is company A. That right there is how much? 200 minutes, right? Look at that. That's 200 minutes. So company B is costing less up to there. And then what happens after 200 minutes? Company A takes over being less, right? Does that make sense? Y'all remember seeing graphs like that? Like one is less all the way up, and then it's flip-flops? Yeah, that's kind of what you got. Okay? It's a really good problem. Yeah, we wouldn't even bat an eye at 150 minutes. Not one bit.
What's that, 2.5 hours?
I don't know. It's 2 hours. 30 minutes.
2.5 hours.
Yeah, that's it. Yeah, 2 hours. See, it's working, I promise you. Okay. Any questions about that? Anybody? It's been a long day. All right, y'all good? Okay, so we're not going to do this problem right here. Okay, so I scratched this. Because this is a good problem, but that problem's not on your homework. So why would we work a problem that's not on your homework? Not that problem. Nor the problem